Welcome to Center of Mass Problem of the Week. For this week's problem of the week, we are given a positive integer k, and we consider sets with 2k plus 1 distinct integers. And these sets have the property that the total sum of the set is greater than an integer m, and every subset of k integers has a sum less than or equal to m over 2, and we want to find the minimum value of m. So the first thing we're going to do is try to establish that we only need to look at sets with consecutive integers. So we have some set a1 to a 2k plus 1, and we have, let's say we look at the higher half. So I is between k plus 2 and 2k plus 1. So in this higher half, we can send each of these ai's, where our I is between these two integers, to ai minus 1. Now doing this will decrease the total sum of the set by 1 and decrease the highest subset sum by 1, because in the second half, the highest possible subset we have is just all the integers in the second half, and so reducing 1 by 1 reduces this subset, the sum of the subset by 1. And so if our initial lowest integer was m, now our lowest integer possible for this set is m minus 1, because the total sum decreased by 1, so we'd want to make sure we decreased m by 1, so the total sum is still greater than m. And decreasing m by 1 decreases m over 2 by 1/2, whereas the highest subset was decreased by 1. So that's a higher decrease of the subset, and so it's still, these subsets will still definitely be lower than m over 2. So we can do this for every integer in the second half, and we'll end up with a consecutive set of integers from a k plus 1 to a 2k plus 1. For the lower half, we can do something similar, where we send each of ai, say I is between 1 and k plus 1. Now these integers are not members of the highest possible subset, so increasing by 1, our highest possible subset is still bounded, and the highest possible sum is still stay the same. The total sum increases by 1, so that doesn't affect our one property that we want to make sure the total sum is greater than m. And so we can keep sending all these integers in the lower half up 1, and we'll end up with our consecutive set of integers. And this is starting from an arbitrary set. So we're only going to look at consecutive sets of integers. So now we're going to write out the total sum and the highest possible subset sum. So now that we know the set is consecutive, the total sum is a1 plus 1, which is a2, and a3 is a1 plus 2, etc., all the way to a1 plus 2k. And this will give us k plus a1 times 2k plus 1. The highest subset is doing a similar thing, but only with the highest second half of integers will give us 3k plus 1 times k over 2 plus a1 k. And now from our initial properties that the set has, we know n will have to be, n over 2 will be greater than or equal to this value, the highest subset sum, and n will be below the total sum of the integers, which is k plus a1, 2k plus 1. So combining these two inequalities, we get this inequality right here. And so this inequality implies this left side is less than this right side. And if we do some manipulation, we'll end up with k squared. It has to be less than a1. So now we want to minimize this value. Sorry, this should be m. We want to minimize this value m, so we want to minimize a1. So we'll say a1 equals k squared plus 1. And then now that we have a1, we can actually explicitly calculate our total sum. So doing that, Okay, so we're going to calculate, I misspoke earlier. What we want to calculate is the highest subset. And so m, by when we minimize m, we'll just set equal to the highest subset. And we know A1, so calculating the highest subset sum, which is m over 2. We get 2k cubed plus 3k squared over 3k multiplying by 2. We get our final answer, which is m equals 2k cubed plus 3k squared plus 3k. And that is our final solution. Thanks for watching. Please check out centermath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.